So, good evening to everyone. So, I welcome you all to this webinar on selection and modeling of motors. So, today we will talk about the motor, like what are the criteria, how the motor selection is being done, and how we model, like we will do some mathematical modeling of motor on MATLAB. So, the content of this webinar will be more about the motor basics. Like first we will talk about the basics, like what are the different laws and how the motor, like on what principles, as well as on what are the different laws upon which the motor works. Then we will talk about the different types of motor, like we will be show the difference in different types of motor according to their supply, like AC and DC motors. Then we will be then we'll be talk about the selection criteria, like upon which factors, like what are the factors upon which the motor selection is being done. Then we'll be talk about then we'll be do the modeling of motor on MATLAB. So first, some basics and law. So we will talk about the laws, like these are the basics law upon which the motor work. So first one is the Ohm's law and the power. So Ohm's law talks about that is the V is equal to IR. So V is directly proportional to the current, and where the proportionality constant is R over here. So this is Ohm's law. Then the Kirchhoff first law, that is the KCL, we can say Kirchhoff current law, in which we can see that the current incoming at a node and outgoing at a current at a particular node is the summation of the incoming as well as the outgoing current at a particular node is 0. Then the Kirchhoff second law, that is the KVL, Kirchhoff voltage law, in which the summation of voltage drop in a loop is always equal to the 0. Then the Faraday law of electromagnetic induction. So upon this principle, the motor works like whenever a current coil, whenever a coil of wires is like we can see here a coil having n number of turns, suppose. So when a bar magnet, like the Faraday, the scientist, he discovered that when the coil having n number of turns, when a bar magnet, like magnet was whenever the magnet is kept near to this coil, so there is some sensation in this ammeter, like there is some deflection into this ammeter. So this is all about the Faraday first law of electromagnetic induction. Then the second law, which is the second Lenz's law. So it talks about that whenever there is a flux linkage in a coil, there is an EMF produced. So and the direction of the inverse is negative. So the negative sign here over here is nothing but that this one is given by the Lenz. So in Faraday, according to the Faraday law, first law, so whenever there is a flux linkage into a coil and it changes with respect to the time, there is an EMF induced into it. So this is the law upon which some motor works. So there are few more laws. We'll be talking about that The second law is that is the Maxwell's right hand grip rule. So like if we have to design a electromagnet, like we in our motor we have electromagnet electromagnet, the conductors like the turns over there are turn, and when there is the turn and the current is being flowed through it, there is the formation of electromagnet, like there is the form of magnet. So this one, the Maxwell right hand grip rule, talks about the direction, like the suppose the current is going inside this conductor, and this conductor is like this wire. So and this wire is turned over a conductor. So when the current direction is in this, like the palm hand, and like we can see the four finger here and the thumb. So when we turn the direction and the four fingers into the direction of the current, so we will see that the magnetic field is at the direction of the thumb. So this is about the Maxwell right hand grip rule. Then we talk about the Fleming's left hand rule, and there are two rules: the left hand rule as well as the right hand rule. So left hand rule talks about the motor. Like in motor, what we do, we give the electricity and then we got the mechanical energy. So there is a conversion of electricity into electrical energy into the mechanical energy. So there are magnetic fields, the flow of current, like motors have the stator as well as the rotor. So according to the different configuration of the motor, like the stator, some stator has permanent magnet upon it, some stators has number of coils over them. So according to the direction of the flow of magnetic field as well as the current, we got the motion, like in which direction the rotor will start rotating. So this is being defined by the Fleming's left hand rule. Then when we talk about the right hand rule, so right hand rule is especially for the generators, like what we can say that in generators. So this Fleming's right hand rule is for the generator. So for generator, we give the electrical input and we got the mechanical output. Sorry. So in generator, we give the mechanical input and we got the electrical output. So we can see in generator, when we give a mechanical input and the direction, due to that rotation, the magnetic field is being produced, and we can relate the direction of the current by the Fleming's right hand rule. Like the thumb, we can see the thrust, the force is in, if it is in the direction of the thumb and the magnetic field is in the direction of this finger, the current will be in the direction of the middle. So this is all about the direction of current in the case of generator. And when it is talk about the motor, the Fleming's left hand rule will be there, and in that Fleming's left hand rule we got the direction of rotation. So this was about the Fleming's left hand as well as the right hand rule. Now we will be talking about the Lorentz force. So we through this basics law, we got to know that the direction of the current as well as the direction of the motion. So now, what will be the magnitude of that particular force? Like at what force by what force the conductor will be start rotating or the rotor will start rotating. So through this Lorentz law, we can get that magnitude of that force. So here we can see that this is the North Pole and this is the South Pole. So magnetic field lines will be from North Pole to the South Pole. Okay. And this is the conductor. We can see here the conductor. So the current is being flowing through it. Suppose if the direction of the current is along this direction, so we can see that by using the Fleming's left hand rule, we can see if we place the forefinger in the direction of the magnetic field, and the current in the direction sorry, and the middle finger in the direction of the current, like this direction. So we can see there is the force which is acting upward. Similarly, when we come to this part, so we can see the magnetic field is along the direction. Now placing the middle finger, sorry, forefinger in the direction of the magnetic field, and the direction of the current in the and the middle finger in the direction of the current, and we will see that the thumb will be downward. So the force direction will be downward. So what will be the magnitude? So it is F is equal to BIL. That is here the magnetic field intensity, the length. So the length will be taking that how much length that is into the magnetic field lines. So that length will be taken into the consideration, and the magnitude of the current which is flowing inside the current. So the product of magnetic field, the current and the length will be force. So these are the basic law which we see into the Lorentz force. Sorry, the working of the motor. Now we will be talking about the different types of motor and the electric motor. So here we have differentiated the different types of motor. The first one is the DC motor, and second one is the AC motor. So in AC motor we have asynchronous motors. The first one is the induction motor, the synchronous and the reluctance. So in synchronous motor we have the rotating, like the motor is rotating, the rotor in the motor is rotating at a speed of ns, like there is the formation of rotating magnetic field, like whenever the supply is being given to the inside the AC motor, a rotating magnetic field is being produced, and to follow on this rotating magnetic field interact with the different conductor, and due to that the magnetic field lines, like all the basics law is coming into this figure, into this overall working of the AC motors as well as in the DC motors. So because of this rotating magnetic field, there is the rotation and there is the rotating of the rotor. So asynchronous, so we can see the phases according to the induction motor. We have single phase, three phase, and according to the rotor construction we have squirrel cage and the one rotor. And talking about the synchronous motor, so the first one is the permanent magnet and second one is the one rotor. So now in AC motor the reluctance motor is also there. The first one is the reluctance. So in reluctance motor this motor works on the reluctance torque, like there are the like force of attraction between the magnetic material and the magnets. So because of that force of attraction, there is the formation of reluctance torque, and they has been separated into the switch reluctance motors and the synchronous reluctance motors. Now talking about the DC motors, so DC motors are being classified into the two types. The first one is the brushed as well as the brushless with the permanent magnet. Also first the brushed DC motor, the first one is the separately excited and the self-excited. So self-excited is being classified as the series wound, shunt wound and the compound, and the compound wound is being classified into the short shunt and the long shunt. So this is the basic difference between the DC motors. So we know that the BLDC motors have the permanent magnet onto the rotor. So can anyone from the audience tell me more about the BLDC motors? Yes, from the audience. Yes, from the audience, can anyone tell me, like, have you guys have any idea BLDC motors?
No, sir.
Okay, so BLDC motors are the brushless DC motors, like compared to the DC motor, the brushed one. So there is are no brushes, like there is no commutation process happening. Where in real DC motors we have Hall sensors, which or we can say they uses the electronic controllers to control the rotating of the rotors. So Hall sensors are used to detect the position of the rotor. So onto the rotor we have permanent magnets, and the windings are onto the stator. So because of the attraction between the windings and the permanent magnet, there is the rotating of the rotor inside the BLDC motor. So in brushless DC motor are of two types. The first one is the in runner, inner one, and the out runner. So in runner motor, the rotor is inside the inside the stator, like the rotating part is into the in between of the motor. But in case of outrunner, or we can say it is the hub motor, so these motors are the outer part is the rotating, like the outer construction is at the outside, and whereas the stator is inside. So we have seen some scooters like e-vehicles, electric two-wheelers, like we talk about the Ola and the Ether. So they have so in Ola S1 they uses the hub motor. So in hub motor the rim is being replaced by the hub motor only, like the outer part itself the rotor, then the tire is being placed upon that. So according to that the VLDC motor rotate. So and DC motor has very much advantages as compared to the brush DC motor, because brushless there is no brushes, so they didn't have any noise, their maintenance is low, and also BLDC motors has high torque, power to weight ratio, as well as the high torque density, high torque. So this is the difference between the brushless DC motor and the brushed motor. So now I will be talking about the flux, like the radial flux motor as well as the axial flux motor. So when in radial flux motor we have the magnetic field lines, which is perpendicular to the axis of rotation. So this is the motor, okay, and this one is the rotor, and this one is the stator. So this is the rotor and this is the stator. So we can see that the magnetic field lines are perpendicular to the axis of rotation. So rotor is rotating upon this axis. Like this is the fixed axis and rotor is rotating, and the magnetic field lines is forming like this. So due to the interaction between the magnets as well as the magnetic field, the rotation happens. So now in case of axial flux motors, so we can see the constructions, like we have here the stator and this one is the rotor part. So the construction is like that, or we can see that the magnetic field lines. So suppose this is the axis of rotation, and the formation of magnetic field lines is parallel to it, like this way. So the benefit of this axial flux motor is that there is high flux linkage, or we can see magnetic field lines are interacting with the magnets, due to which the axial motors are provides a high torque density, as well as they have a good power to weight ratio as compared to the radial flux flow motor. So these are the basic difference between the axial flux motor and the radial flux motor. So we have the Rolls-Royce, Yasha, Marex, and AMK. So they are into the R&D of this axial flux motor, like they have developed some vehicles which have been using this axial flux motors. And here are some benefit of the axial flux motor, like we can see that the power to weight ratio, it is 8 kilowatt to the per kg, like 8 to 12 kilowatt per kg, which means that 1 kg, suppose like the weight of, in our EV the weight is also a factor upon which the range of the EV depends. Suppose we are using a motor of heavy weight, then there will be the range reduction. So if we have a higher power to weight ratio, that means in small kg, like if the weight is low, we will get the more amount of power. So having this power to weight ratio high, we can use this motor in our electric vehicles as by because these motors are lesser in weight and they provide a high power. Now axial flux motor reduction is in weight by 20 to 30% due to the yoke elimination. So we can see that in the motor constructions we have yoke which are onto the stator part. So in axial flux motor we didn't have yoke. So due to the yoke elimination, we see the reduce in the weight, like the weight is being reduced. And also they provide a torque because I told already that the magnetic field lines is parallel to this parallel to the direction to the axis of rotation. So there are more flux linkage, so they provide better torque. And also the same torque is required for the 40% copper winding. So the copper winding also reduces because we are using we are getting the flux linkage of similar to, like if we are using that radial flux and the axial flux, if we want the same rating, so in axial flux motor the copper will be lesser as compared to the radial one. So this is the difference between, mainly difference between the axial flux motor and the radial flux motor. Now the selection of motors. So the selection of motor is a very important factor, because if we are designing an electric vehicle, so we are considering the battery, the motor, the controller. So the weight, like how much power, like what is the requirement, how we should proceed to the requirement of what are the essential criteria for the selection of the motor. So the first one is the power required. So first we take a vehicle, we design its weight, so we define its weight and also the different forces which are acting upon a vehicle. After selecting that, calculating the power requirement, suppose we want X Newton power and the torque, and this much torque is required to rotate this vehicle, and this much force is required to move this vehicle. So according to that we go for the motor selection, then the size and the weight. So also the motor size is also a factor. I already discussed in the previous slide, like we require less weight and high power. So if we are using a lower weight and the high power, so taking this factor, the size as well as the weight of the motor is also an important factor for the selection of the motor. Then the second one is the efficiency. So we can see that which motor is more efficient, and also like there should be no more power losses, and the efficiency of the motor should be high. So so efficiency is also a factor upon which the selection of motor is based. And also the cost. So talking about the cost should be also less as compared to the other, like if we do the comparison, like the motor should be also cheaper. And the last, and also the control part, like to control the motor, what is the controlling process, because we are using these motors into the electric vehicles, and we know that driving electric vehicles are very dynamic things, like we have to suddenly stop, suddenly increase the speed and decrease the speed, and also to control the speed of the motor, so controllers are being used for controlling the motor speed. So the controller cost, how we are implementing the controllers onto the motor, so that is also a factor upon which depends. There are this factor is also a key component for the selection of the motor. Then we'll be solving an example. I will be taking an example like if I want to do a short calculation, like if I am designing a vehicle which is of 1200 kg, and let's suppose I want the motor selection at 100 km per hour, and for that particular vehicle I also want the range. So the range I am taking about 150 km. So what will be the power the so what will be the power required, like what rating of the motor I will be requiring to attain this configuration, so that this 12 kg weight, the 100 km speed, and also the range I will be also taking. So one by one we'll be talking about the how we should do this type of calculation. So first one is the calculating the power. Like in our motor we have into the motor plate we have the power rating as well as the torque rating. So power rating, and second one is the torque rating. So how we proceed, we'll be talking about it. So the first one, and the first formula, like the formula we should remember, like the torque is the force and the wheel radius. Like what is the wheel radius we need to know. The second one is the second formula is the force. So which is the mass into the acceleration, and the second one is the power. So for power we have force, into velocity upon efficiency. So efficiency of the motor is also taken into the consideration, because if we are not considering the efficiency, the power maybe we get the in lower amount. So first for acceleration I will be calculating the acceleration. Suppose I am taking the acceleration which is about 0 to, like I am defining my vehicle speed, that is 0 to 60 km per hour in, let's take 9 seconds or 10 seconds. So I am taking the 9 second here. So here the acceleration I will be getting is this distance minus the final distance, and so the acceleration will be final velocity minus initial velocity and divided by time. So if we start calculating, so kindly can anyone from the audience can tell me what will be the acceleration here, like velocity final minus velocity initial depending, and this one is the 90 second. So V final is here 60 km per hour. So kindly convert it into the meter per second, and V initial will be 0. What?
2.7.
V final.
No, acceleration.
Acceleration 2.7
meter per second.
You sure?
Because the initial velocity is 0, final is 60 km per hour.
60, not 60. It's 60.
Yes, 60. That is divided by 9 seconds.
Yes. So you divided 60 by 90, or you did the conversion of 60 km per hour to meter per second?
62 meter per second.
6 point something meter per second.
No, just I am taking the 60 into 60 km per hour. I want it into the
meter per second.
yes, meter per second.
Yes. 20 by 5. 20 by 5.
No. See, 60 kilometer to convert the meter into kilometer per hour into the meter per second. So what will we do? We will multiply by 1000 and
16.6 meter per second.
yes, 16.6 meter per second. So if we divide it by 9 seconds, so we will get approx 1.8. 1.8 meter per second square. So this is the acceleration we got, which is 1.8.
Sir, once
Yes.
explain again.
What?
Sir, those formulas are not clear, sir, in the presentation. Could you please explain?
Okay. So initially I have taken a velocity vehicle of mass 1200 kilogram, and I have the desired speed of 100 kilometer per hour. Then I have taken the range of that particular vehicle is 150 kilometer. So I want the motor so that my vehicle could withstand this load. Okay, so this much requirement. So for motor selection, we go for the power rating as well as the torque rating. So for power rating, my first process is to calculate the power, and then second is to calculate the torque. So for power, we have the force into velocity, and which is divided upon the efficiency, because motor will have some efficiency, so it is being divided into the efficiency. So force into velocity is the power, which is divided by the velocity efficiency of the motor. Now force, here we can see the force. So force is nothing but it is the mass into acceleration. So here I have calculated the acceleration, and I have assumed that my vehicle is going 0 to 60 kilometer per hour in 9 seconds. So my acceleration will be v final minus v initial, which is divided by the 9 seconds. So afterwards I got my acceleration here also. So acceleration I got it is 1.8 meter per second. So I got the acceleration and I know the weight of the vehicle. So I will be calculating my force. So the force will be what? 1200 into 1.8 meter per second. So what it is? Yes.
Yeah.
Thank you, sir.
So what is the force here?
Force equal to 1200 into 1.8.
8. So what it is? Twelve hundred into 1.8. So it is near about 2160 2160 Newton. So I got the torque here. Now I am assuming, and so I will go for the torque. So in torque we have the force, but I want the wheel radius. So let us assume that wheel radius is of 0.3. So we 0.3 meter. So I will be calculating torque here. So I got the force, which is 2160 into 0.3. So once we calculate 2160 into 3, we will getting approx 648 Newton. Yeah, 648 Newton. So I got the torque, I got the force. Now I want the power. So power is here, force, and the
that is Newton meter.
yes, Newton meter, yes, yeah. So now I want to achieve the so here what it is, the power. So for power, the force. So first I have calculated here, and the velocity. So velocity, my velocity is 100 kilometer per hour. So I will be convert it into meter per second. So can anyone tell me that what will be the answer? 100 into 1000.
Sir, I have one doubt, sir.
Yes.
Sir, from 0.3 wheel radius, how to come, sir?
So if you are taking the wheel, okay, so you measure the wheel radius, na? Like torque is what? Force into the radius, like from which it is rotating.
Sir,
think you
but
got it.
practically 0.3 meters is possible.
See, I am just taking the assumptions here. Like this is how we proceed to do the selection of the motor.
Okay, sir. Okay, sir.
Okay, like 300 centimeter it is. I am just assuming. Okay, so where was I? So I am going here for the power calculation. So I have the force here which is 2160 and my velocity is here 100 kilometer per hour. So what I will do, convert the kilometer per hour into the meter per hour. So by converting, how much I will be getting, can anyone tell? 1000 divided by 36.
Sir, what is the acceleration 16.6 divided by 9? What is the sum?
Yes. Yes.
Acceleration is the initial minus final upon the
Yes. Initial minus final into the time taken to attain that velocity. So this much is 27.7. Okay. So my force is this one and my velocity is this meter per second. So when I do the calculation of the force, the power calculation here, so what I will be seeing that the force is 2160 into 27.7, and let's assume that the efficiency of this vehicle is 0.8. Okay, 85. Let's take 85. So I will be doing here the reduction of 0.85. So this calculation will give me the force requirement of the motor. So let's calculate 2160 into 27.7.
Sir, are we assuming that it's 85% efficient?
Yes, we are assuming that. So if it, yes,
Sir, write in a new template, sir, where you are writing unable to see.
here.
703.9.
That is the answer of this 22,160 into 27.9 divided by 0.85.
So 703.9.
703.9.
Yeah, sir.
Okay, 2160 divided by.
Where you get 27.1 velocity?
What? 27. So I assume that now my vehicle is moving at 100 km per hour. So kilometer per hour. So I convert the kilometer per hour into the meter per second. So to convert the kilometer per hour into meter second, we do multiply the kilometer into 1000 to get meter, and for hour into second we multiply by 3600. So we will get. So my answer I got it here is 70.390 kilowatt. So this much power of motor I required to rotate my vehicle. So the power, so here I have calculated the power and the torque. Here it is 648 Newton meter. So this much of torque and the power rating motor I required to drive my vehicle, which is of 1200 kilogram, and I am driving that vehicle at 100 kilometer per hour, and the range I am estimating here it is 150. So currently here there is no use of range. So for battery pack I will be taking that. So I think you have understanding that how we initiate to do the selection of motor.
Sir, then why did you take 0 to 60 km per hour?
For acceleration.
Already given 100 km per hour.
So that is the speed that I want to maintain. Like I want to maintain. Listen here, I am just assuming like this is how we proceed for the calculation. So for actual scenario we use drive cycles, like there are very much ups, down, ideal condition, the acceleration, deceleration, regen thing. So in that scenario we go in more details, like there are more complex things happen into the selection of the motor. So upon that driving cycle, based upon that we select the motor. I am just here giving you an overview that I have assumed these things and how I initiated my motor selection thing. So this was about the motor selection thing. Then then here are the some vehicles which are using electric motors, like we can see here the Ather 4X1. So they are using BLDC motor, and the motor is here, it is 8 horsepower and 26 Newton meter. So I already told you that into the previous calculation we were focusing on power as well as the torque. So here the motor rating is being of this particular vehicle is being mentioned. For this one is for the Ather, and for this is the TVS IQ, and it is also using the BLDC motor, and the rating of this BLDC motor is here 6 horsepower and 140 Newton meter, and they are providing the range of 75 miles. And the Bajaj Chetak, so it is also a BLDC motor, so it is also delivering the power rating as well as the torque rating is mentioned here. So I was talking about the hub motor as well as the mid motor. So hub motor, so this rim itself will be the motor here, like the stator will be inside and the rotor will be outside. So this is the construction of the hub motor, like the motor, the wheel is itself the motor here. So I think everyone is clear. Anyone else have any doubt or any questions, or we can proceed further?
Hello. Sir, one question.
Yes.
Sir, can we get recordings afterwards?
Yes, you can get, I think.
Can you please send this recording also? It will be benefited so that we can listen again.
Okay.
Hello,
So,
sir, one question.
Yes. Yes.
Can you go to the previous slide? So here, the first Ather 450 and the next TVS, that motor, if we compare, here it requires 6 HP, and in an Ather it requires 8 HP, but the torque is more in Ather, and
so maybe
so the speed is different, right?
So let me confirm first. So maybe this difference is due to the weight of the vehicles, and also the battery pack. Like maybe the Ather is using the battery pack of different capacity, and also the TVS is using the battery pack of different capacity. and also there will be some difference upon which this motor of different rating is being used into this ether as well as the TVS.
Okay.
So now coming to the motor modeling part. So this will be, I will be showing upon the MATLAB. So here I will be do the mathematical modeling of this DC motor. So here we can see I have converted the motor into the electrical circuit and as well as the, so this from this circuit I will be getting the dynamic equations of the motor, like what are the electrical equations and the mechanical. So by applying the different laws, Kirchhoff's as well as the Newton's second law, so we will calculate the dynamic equations of the motor, and based upon that equation we will be do the modeling upon the MATLAB. So here what I will be taking, so my input will be the voltage applied. So whatever the voltage I am giving to the motor, so that will be the input, and based upon that I will be taking the output. Like my output shaft will be the theta, which is the position of the rotor, like at which position this rotor is being rotated. So there are many things. So once we start designing a motor onto a MATLAB, so there are many things like when the rotor position is where, how we develop the controllers into it, what is the control system, how we define the control system upon it. So there are many things on this motor modeling. So I will talk a basic thing here, that how we do the dynamic calculation, dynamic modeling of motor here. So here I can see that we have here, this one is the torque and theta is the angular position of the rotor. So coming to the next slide. So from Newton's second law I have taken here. So from Newton's second law, so it will be acting here. So the torque will be equal to the different. So the torque here it will be. So let's suppose. So this is the torque. So torque here will be J d theta square. So this is the from the Newton's second law I got this equation, like the torque. Here J is the moment of inertia, and here the d theta is the angular acceleration, and here the B is the motor viscous friction constant, like the friction which is acting upon a vehicle, and d theta by dt is the velocity. You can see the angular velocity of the rotor part. So and also the Kirchhoff's law is being implemented here. So by applying the Kirchhoff law, like the KVL, so after applying the KVL we will be seeing that minus V plus, the current is going inside, it is the d I into R, and here it will be L di by dt, the current into the inductor, plus EV. So here EV is the back EMF. So once we configure this model and we try to make it like this. So for the Kirchhoff's law, the electrical, and this is the mechanical, the rotating part, I got these two equations. So here are the different parameters, or we can say the different values which we are going to take into this model. So one by one I will be showing you how to develop this equation into this MATLAB. So let me wait first.
अभी हाँ तो मैंने देखा मतलब हेलो the session is over
Sure. So is my screen visible?
Yes sir, yes sir.
Okay.
Yes.
So I have used that model and I have developed my yes. Okay. So are the equations which I have shown you into the here. So this was my model. So I have implemented this model into the MATLAB.
Why?
hello hello
Hello.
sir how to implement the formula in MATLAB
So here I am showing that one only. So here the first one is the d theta by dt. So here I want the angular position, like my theta will be the output and my v will be the input. So first what from the equation I see that I want the double differentiation of the angular position. Then I also want a single differentiation of the angular acceleration. So first of all I made d theta. So I have taken an integrator. So for double differentiation I will be using a double differentiator and I will be get a single integration of this differentiation of the d theta. So and initially I built a line. Sorry, I have taken an integrator. Okay. So I have taken an integrator here and I have implemented I again use the integrator. So I named this line as the d2 theta divided by d2 square. So once I integrate, it will be giving me here the d2 theta will be become d theta by dt, and if I again use different integrate that one, that will give me theta. So initially I get my d theta and I integrated to get my d theta by dt. Then I integrate again it to get my theta, because theta the angular position I want. Then I go for the further things like kt and ki, and this one is the d theta by dt. So here kt is the torque constant, so into I. So what I will be doing, so I will be using a summer here. So I can see here the kt into I is the addition part, and this one is the negative part. So I am using a summer here. So in summer what I observe, get my d theta. So the d theta will be multiplied by b, and when the summer negative is being connected to this one, my d2 theta into dt by dt, and also the kt here is the it. So I am taking the it because the it is the previous part, and also here I want di by dt. So di by dt. So I again use that thing, like I have observed, make here I, and I use an integrator before that. So before that line I have here, that is di by dt, because I want the di by dt into the Kirchhoff, from the Kirchhoff law I am getting that the di by dt. So I simply use this kt into I and I got this equation. So overall this Newton's second law, or the the rotor position part is here. Then I forward to the Kirchhoff's law. So di by dt. So and here the overall multiplication is by j. So d square theta by dt square is the equal to the j 1 by j into the summation of this one kt into I, and here the b into d theta by dt. So this is I calculated, I model my this equation, then I proceed to this equation. So here I have the di by dt, so it is equal to the IL 1 by L. So here I have used the gain here 1 by L, so it is final coming to the di by dt. Then what I require here is the summation, like I want 2 subtractive and 1 additive. So I used a summer here, so addition, subtraction, subtraction. Okay, so for first one I used the r into I, so I got here I, and I use the gain here which is ri, and I then add it to the summer here. Then I use the v, so v here is my input, because I already mentioned that v is my input, so I will be giving my input according to my convenience. And also the k theta, because here the d theta by dt are interlinked, so I use this d theta by dt multiplied by kb. I use again gain here, then I subtracted it here, and I have 1 by L multiplied to all this. So I use the gain here, and I have taken 1 by L here, and then I feed it to the di by dt. So this is how I model my block. Okay, and then I have gone to my MATLAB workspace. I have given the different values for the j, b, and the kb, kt, r, and l. So and I run my project. So I will run here.
Hello.
Yes.
Sir, these values how to get?
So you can go for any example, like you can go for any research paper, reference paper. From that you can get this value, or even you can follow a book. In that book you can get and take any example and start modeling into the MATLAB.
Sir, how to learn math?
So how to learn MATLAB? So if you want to learn the MATLAB, you should know the basics. Like we have different sources for that MATLAB learning. You can go to that. So here this is how I designed my MATLAB, this model, and when I run it, so I already ran in, so I will run it here. So here is my scope.
Hello.
Yes.
Hello.
Yes.
Sir, how to learn MATLAB?
Yeah, for learning MATLAB, you should know the basics, fundamentals of each and everything. Like if you are going to design a motor or converter, so you should know how the mathematical equations are there, how the working is there. Then you come to the MATLAB and start learning through the different resources you can use to learn the MATLAB, like the MATLAB, mathwork of the MATLAB.
Which platform I need to join?
So in ISI India, you have also the courses related to MATLAB, like we have here, and also in YouTube.
What is the package of MATLAB?
Yes.
What is the package of MATLAB? How
For this you need to contact the time you are asking, or what you are asking?
No, money.
So for you contact the management team. I am not
Okay.
So here I got my output here. So my initial voltage here at this step, I have applied a step signal of voltage, and my step time is 1, and my final value is 1. So that which means that after 1 second I am applying a volt of 1 volt, and after that I got my answer. So we can see how the theta is position is being changing per second. So at till when I didn't apply any voltage, we have zero rotation. But when I apply the voltage, I can see that the theta is going increasing, like 10, 20, 40 over the time period. So this was all about the mathematical modeling of the motor. So through these equations, I model the overall DC motor, and to get so we can implement many things into the MATLAB, they might be controllers or anything. So till now, this was from my side. So any questions you can ask?
How to get the certificate? Because of when we have attended this session.
Okay, so for this you need to contact the management team. So management team will be saying these things to you.
Okay, sir. Okay, thank you. The session was very good because of a lot of things.
Okay, thank you, thank you.
Sir, if we change the type.
Yes. So someone is
the
asking me the feedback link. So for feedback, if I am implementing the controller then I will be requiring a feedback link there. So for implementing, so if we move more deep into the motor controller things so there I will be requiring the feedback link there. So here I didn't use.
So can we get PPT and video recording?
So all these things you will be you need to talk to the management team.
Sir, if we change the model of vehicle, then what?
Okay. So apart from this, if you have any doubt into the webinar thing, so you can ask, or else I am concluding the system and I am forwarding the session to the ISIET. So if you have any question, you can ask, so I am forwarding the session to the ISIET.
Sir, if we change the vehicle, sir, type of vehicle,
yes,
then what are the motor type? It will
like
change or not?
for higher motors, like 4-wheelers, they are mostly using PMSM motors. So because of they are providing a good starting torque as well as the good power to weight ratio, so we can go for PSM motor. So in 2-wheelers, we are mainly using this BLDC motors only.
Rickshaw like a 3-wheeler, sir.
Yeah, 3-wheelers, they are using BLDC motors.
Thank you, sir.
Sir, which motors do 4-wheelers use?
PMSM motors they are using.
Yeah, it's the permanent magnet motor, yeah.
Yeah, permanent magnet synchronous motor.
Okay, sir, thanks.
Sir, for motor selection, do we always follow this method, like what you said, like calculating power and?
Yeah. We either go for mathematical things or we go for the MATLAB things. So in MATLAB we have, because designing a vehicle is a very dynamic thing. So we put that vehicle model into the drive cycle, which is into the MATLAB. And then according to that curve, like whatever we have implemented, we get the idea of like with this capacity of motor will be used for this particular vehicle specification. So this the calculation which I showed is a brief idea which I have given to you, so that you can understand the basic understanding of the selection of the model.
Okay, sir.
Thank you, sir.
Anybody is having any other question?
So how to get the certificate?
The certificate will be sent to you through email. You will get the process to download the certificate from the website. Okay.
Okay, sir. Could you send the PPT?
I hope all of you have liked this session and the content delivered by our expert. Thank you, sir, for delivering such a wonderful session to us. Furthermore, if you guys are interested to learn more about the motor selection, its designing and component selection, you can join our specialization course in motor selection. You can inquire the course. The link for the course is given in the chat box. You can click the link and you can fill the form for the inquiry.
Sir, could you please send the PPT?
We will share the link of this recording with you if possible.
Okay, sir. Thank you.
If you guys are looking to join the course in motor selection designing, you can find the link in chat box and you can fill the inquiry form.
Okay, sir. Sir, how much the course?
Sir, course का duration क्या है sir?
It is of 1 month course.
How much you charge, sir?
It is of 8,499 rupees.